Sets. In this video, we will learn about sets, their pros and cons, as well as their use cases. The code for this video and its script documentation styled with nimip is in the link in the description as a form of offline tutorial. What are sets? Sets are a data type that can only have ordinal types for its elements. They model a mathematical notion of a set. In short, sets are a simple data type that is extremely performant and can be operated upon with distinct mathematics operations. That makes it very easy to determine what belongs to what. Here is an example to make you more interested. Say you want to download some files from a remote computer via the File Transfer Protocol, FTP. You can create a set with a listing of your local files and another with a listing of the remote files. Then you can easily create a set of only the files you need to download, like this. Files to download is remote files minus the local files. Now let's get into the details of sets. They are allocated on the stack. The size of a set when using signed integers is 0 to default set elements minus 1, where default set elements is currently always 2 on the power of 8, while the maximum range length for the base type of a set is max set elements, which is 2 on the power of 16. Types with bigger range than 2 on the power of 16 are forced into this range. This is because sets are implemented as high-performance bit vectors. The order of its elements is unordered. There are also hashsets that can have more types than just ordinal and can be ordered, but that is the subject of another video. Now let's make an empty set declaration and initialization. So var empty set curly brackets. This is the constructor for sets, but it doesn't work since we gave it no data type, so the compiler cannot infer its type. So let's comment this out. And now the declaration var empty set as a set of characters. And then let's just echo it. One thing to note is that one cannot access sets with square brackets by the index, like so. Say the 0th one, even if this had any elements. The way to access sets is the following. Let's make a new set, call it access set, is curly brackets, the constructor. Let's give it character A and character B. And then again, like before, if we try to use the square brackets to access it, we can't. The Visual Studio extension for nim catches it already. We have to do it in the following way. You can use the in keyword with an if. So if, let's say, a character in our access set, then we can echo that a is in access set and run this. Here we go. A is in access set. We can also use the contains proc to do the same as the in keyword. Also, there is the negated version, not in. So if we run this, it's not going to display this message. Here we go. Now, sets can only have unique elements of ordinal types. Any duplicates are removed. So let's make another set for duplicated set and give it 2 A's, 2 A characters, and then run this, display, duplicated set, and run. As you can see, the other A got removed. this is one of the use cases for sets, for converting a data type into a set and back to lose all the duplicates. Now that I have mentioned that sets can only have ordinal types multiple times, let's see what those actually are in code. So var type section, and we start with integer 8 set, let's call it, and then set integer 8. Then there is the integer 16. And the next one will be char for characters. So char set as set of char. And lastly, enumerators. So let's call it enum set is enum. And then for its enumerations, let's just S1, S2, and S3. Maximum size of a set is 2 to the power of 16 bits for reasons of performance. hashSets do not have such limitations. Here is a list of all the unique procs for ordinal types. Like with every container construct in NIM, we can also use a for loop on them. So let's use a for loop on our deduplicated set for E and deduplicated set, and then echo E. Here we go. And here is the list, full list of procs that you can use to operate on sets. Let's start with difference between two similar sets. So let's make two sets, var set A, and give it AB characters, A and B, and then set B, and give it A and C, A and C, and now echo set A minus set B difference, and run this. Here we go. The difference between them, set A and set B, is B. If we reverse the order of this difference, we're going to get a different result, and that will be C. What is happening here is that we're basically subtracting between these two sets. So since set B is being the first set in this difference, so set B has A and C minus set A, which has A and B. So these two are the same, so they can subtract between each other and become 0, removed. And then C remains because C is not equal to B. And if we add another character to set B, let's go with B. So set B minus set A, so A and B, these two are going to be removed, and C will remain, like so. And if we reverse this, nothing will remain, because set A only has A and B, and set B also has C for it to remain. But since A minus A, B minus B, this one becomes empty, like so. Now let's move on to unions. We don't need this element anymore. So if we use the plus sign instead of the minus sign, we are going to combine these two sets together. So ABC. A is in both of the sets, so it only gets displayed once, no duplicates as well. And then B and C, all the elements of set A and B. In order to add or remove elements of sets, instead of using the add and del procs that sequences use, strings only have add, we can use the incl, short for include, and excl, short for exclude. In order to add or remove elements of sets, instead of using the add and del procs that sequences use, strings only have add, we use the incl, short for include, and excl, short for exclude. So let's try them both. So set A, we will include character D, and set B, we will exclude character A. And then echo them both, echo set A, and echo set B, and run this. Here we go. Set A got the character D, and set B lost character A, and is only has now the element of C. There is also the equality check, which checks if both sets, their members, and their size is equal, and if they are, it's exactly the same. Now let's continue with the intersection operation, which is done with the star sign. Intersection means elements common shared between both sets. Right now our sets have none of those, so let's add them. So set B include A, and set B to include B, so that they're equal, because set B only has element C right now. Now let's echo this with the intersection. So set A, star sign, set B. And let's also reverse this to get both results. Set B, star, set A, and run this. As you can see, reversing here doesn't do anything, and A and B are the shared elements. Now let's continue with subsets. Subset meaning if set B has the same elements that set A has, but not all of them, just a part of them, since in order for a subset to exist, there has to be a set larger than its subset. The best way to demonstrate this is with two subsets. So let's add another. And also display all three beforehand so we can see what's going on. First, let's comment this out. And now let's add set C and give it two elements of A and D. Then echo all three. Echo set A, echo set B, echo set C, and an empty one to get some separation. And then we do the subset testing. So set B to be subset of set A, and echo set C to be subset of set A. Now let's run this. Here we go. Set B is not a subset of set A. This is set A and set B, because as you can see, set A has A, B, D, and subset B has C, and this one it's not in it, so it's false, while C has A and D, which are both in subset A. Now, even if we remove this different element of char C and replace it with char D to make it equal, subset B is still not going to be a subset of set A. That is because set A has to be larger than the subset. Let's test this out. We gotta put it up here. We still see everything. So set B to exclude C and add D to make them identical. And this. Here we go. They are now identical, and yet it's still false. Set B is still not a subset of set A. This operation with the smaller than sign is strict. But if we add the equal sign to make it smaller or equal to, it is no longer strict, meaning that subset B no longer needs to be smaller than subset A. Let's show this. True. Again, this one is not as restrictive. And lastly, there is the card proc, which returns the cardinality of a set. its number of elements. So let's echo all three with this to get the length. Here we go, 3, 3, 2. You can still use the len proc like with other containers that we used before. There are also integer sets, int sets module for efficient integer sets. And there is also the std set utils module for a bit more utility for sets. And now let's move on to two very useful use cases for sets. The first being using sets with enumerators to produce flags. Okay, so let's firstly create the enumerator for the flags. So let's call it sandbox flag is enum. Let's give it two flags, enumerators. Allow cast, let's say, and allow infinite loops. Now let's make a set with these. So var sandbox flag. Yeah, let's name it the same as set of type sandbox flag. And now let's add these two flags. So sandbox flag that includes allow cast, copy paste, allow infinite loops, and let's echo this sandbox flag. Here we go. Allow cast and allow infinite loops. Now, if this example wasn't that great for you, you didn't understand, I can also make another gamey one. So let's make another one. Flags is enum, and let's give it walk, attack, and defend. Now we make the set with these flags, enumerators, but flags. Var moves as a set of flags. Now let's add all these moves. So moves that includes walk, moves that includes attack, and moves that includes defend, and echo. Here we go. Not much different on the first glance than when we used a similar enumerator with a sequence, but the operations you can do with enumerators in a set change the game. Now, the second use case is for parsing data. In the following example, we're going to make a split proc that will use a set of characters in order to search and destroy any of the characters specified in our set. Firstly, I'm going to need the strudels string utilities module. Now I'm going to make a proc called split that will split a string using a set of characters. So firstly, let's give it as a string for the first argument, and then seps for separators as a set of characters, and then with these constructors, and let's give it an empty one for empty space, and then for exclamation mark, and for a question mark. And it's going to return a string, a split string. Now I need two variables. The first one will be to copy this string, because this proc will not change the original string, but make a copy of it. So we can work on it. So I need another variable to make that happen for us. Is s. And then I need another variable for the find function that I'm going to be using from the string utilities. Let's call it c as an integer. And now a for loop. for every separator in separators set, we're going to now find one of these elements. So we're going to save that in our C variable. So split string, our string dot find, and then the separator, all of them, loop through them, and then we're going to delete what we find. So split string dot delete, and C because this is a range. So if position is, let's say 2, if you give it 2 to 2, it's going to delete that character. If you give it from 2 to 3, it's going to delete 2 characters. And now we save the data. The result is split string. Now we need some sample string, so let's call it my string is hello, and we're going to use all 3 of these elements. So an empty space, and then world with an exclamation mark and a question mark. And now we echo it to see the original one so we can compare, and then a split one, my string dot split, and run this. Here we go, the original string and the modified split string. Now let's move on to set pros, cons, and use cases, many of which I have already mentioned and shown here, but it's always good to have such a list of condensed data so that one may check it again to know when to use sets. Set pros. The first pro is that sets are extremely fast due to bitwise operations happening behind the scenes, along with being limited to 16 bytes ordinal types. And the second is that there is a ton of powerful operations you can do with them. Membership testing, deduplication, and distinct mathematical operations. Set cons. There is no easy way to access an element's data without changing a set's data to a sequence or another container construct. Sets can only store elements of a single data type and only ordinal types. There are also hashsets, which can be ordered and of any type you want, but obviously a bit slower. Use them if you need set operations and normal sets don't cover your data type. Sets are also unordered. Don't use them if you really need order. Example, you want objects of, say, bullets in a game, ordered by time created, so that you can destroy them to free memory and not have the game crash due to way too many bullets being rendered in the game. One way of optimizing games with bullets is to remove them after a certain amount of time, another is to remove them when they go out of bounds, etc. Set use cases. Say you want to download some files from a remote computer via the File Transfer Protocol, FTP. You can create a set with a listing of your local files and another with a listing of the remote files. Then you can easily create a set of only the files you need to download. Files to download is remote files minus local files. Another use case is removing duplicates, deduplication. Another is ownership checking. Another is that, say you made your game with a bunch of controller objects, which are then checked for their existence, and if they do exist, say object SFX, then sound effects will play. Otherwise, the game will have no sound effects. Or if you want to enable or disable debug mode. This can again be done with other such constructs, but if your game has a ton of objects that were in such a way, then they could all be checking for existence of controller objects to do their function, which would get really slow with sequences. Another use case is the first that I demonstrated earlier, setting compiler flags by using sets with enumerators, or moves a unit in a game can do. And the last is the last example, parsing data. Okay, That's it for this video. Thanks for watching. Like, share, and subscribe, as well as click the bell icon if you liked it and want more. You can also follow me on Twitter of the same name and support me on Patreon. If you had any problems with any part of the video, let me know in the comment section. The code of this video, script, and documentation are in the link in the description. Is a form of offline tutorial. Have fun!